So agenda today is not very packed. So we have a demo that I will show how to create a new policy from scratch. Like if you want to contribute to Kuma, it's pretty easy to create new policy, and I will show how. Then we will have time for Q&A and maybe discuss Kubernetes probes. Yeah, so we have Jan, is it correct? Jan? Yeah. And so yeah, let's start. Let me share my IDE. Let me share everything. So yeah, if, for example, you just was browsing web and you notice that Envoy has a lot of capabilities that Kuma is not supporting at that moment, and you want to have something, you want to use something, but you don't want to use maybe proxy, mesh proxy patch or proxy template, then you can create policy. So for example, you notice that there is a compressor in Envoy, so you can compress requests with different algorithms, and you want to contribute that, you can do that pretty simple. You go to the IDE, you search for new policy file that's in the guides, docs/guides directory, and this guide tells you what exactly you should do. So there is a command, you can copy that, you can open terminal, you paste this command. So it says name of the policy. For example, we will use mesh compressor. As you can see, I already did that. Compressor. Yeah, then you select what type of policy you want to generate. It can be either outbound or inbound policy, or maybe it can be inbound and outbound policy at the same time. So if this is outbound policy, we will add flag generate to section. And yeah, we have force just to overwrite if we have some garbage in this directory. So yeah, we can run this command. And this command creates directory inside. So let's take a look. It's package, and then plugins, and then policies, and then we have our mesh compressor directory, and we have all these files. You can open this one that's called mesh compressor. The next thing you should do, I'm pretty sure we have this here. Yeah, if you want your policy to be not in demo, not as demo, but for real, you should remove this skip registration bit. So let us do that. And then you can see that there is already target ref and to section that we generated. The only thing you should do is define conf right there. And we can define new type, for example, compressor type, which is string. And then we can define some constants. For example, what do we have here? We go to the reference. We have 3 available constants at the moment. Let's implement at least one. Let's make it gzip type compressor type equal gzip. Yeah, and then you can create field type compressor type, and don't forget to put JSON tag here as well. So this should be enough, and now we can call mesh generate policies mesh compressor.
I think policy, singular.
Yes, thank you. I was just checking if people are following. Yeah. Yeah, so we generated this policy, and we can check now what files do we have. So the first one I already explained. This is a Go struct that defines the schema of your policy, but at the same time you also have schema in YAML format, so you can validate this. Yeah, if you do make check, it will regenerate actually everything. Yeah, that's true. Yeah, you have schema, and Kuma will validate resources that user creates using this schema. You also have a validator, and this validator has some places for you to implement the validation, the logic. Also, you have deep copy generated, you have helpers, you have a resource for Kuma model, like to use internally in Kuma to work with your policy. There is also Kubernetes section where you have customer source definition, and you have plugin. That's the part where you will put your XDS configuration. So you will check the policies that's coming into this method. You will take all the resources that were already generated, and you can create the actual compressor by looking at the policies that were matched for your proxy. So this is pretty much it. That's what you have. If you call this command, and I think it's pretty simple. So feel free to contribute new policies to Kuma. And let me, do you have any questions for this?
Maybe it's worth showing an example of like apply.
Apply? Yeah, sure.
Right, just, you know, I don't know, probably a simpler one is mesh trace, for example.
Oh, sure. Yeah, I was
Like
thinking
one that is already implemented.
Yeah, sure. Mesh trace, of course, we can show the how it's implemented for another policy. So we have plugin. Yeah, so you take policies from this dynamic map, you take a mesh trace type that you want to implement, and then you check the rules that were matched. You also can find them in the policy structure. Usually, you do something like that, like apply to inbounds, apply to outbounds methods. In case of the new policy compressor, it will be only apply to outbounds method. Yeah, and then you just take data plane, you iterate over the outbounds, and you call configure listener or something like that. And in this listener, this is already Envoy structures. So you take listener, you iterate over filter chains, and you configure each filter chain respectively. I think
right.
I think compressor is HTTP filter, so you will probably you should take probably HTTP connection manager, and then take HTTP filters, and then put your configuration here. Yeah, so this is how it works.
And from a registering point of view, etc., if you were to start the CP right now, you would be able to see in the GUI, like, and everywhere in the CRD, etc., you would, like, your new mesh compressor would be registered, right? There's nothing extra to be done.
Oh yeah, but you have to call generate policies, because I think it's
right, which is part
it
of
needs to generate
check,
imports, and other stuff, but we can check that as well. Oh yeah, okay. I think we need to just, there's weird bug with patching the YAML values file. Yeah. So as you can see, we added mesh compressor here to the list of policies. We also added import file. So that it was actually registered. And then now we can run Kuma CP, for example. And if we go to the browser and check the, will we see this in GUI?
Yeah, in policies here in the dropdown, it should be here.
Yeah,
Mesh
here.
compressor, right?
Yeah,
There's
it's already
none
here.
because you haven't created any, but
Yeah, and exactly. And if you check mesh compressor arrest.yaml, there is Swagger that has already method defined. That's why this all should work, I think, if you do just this. So yeah, you will see that this endpoint's already defined in Kuma.
yeah,
So
and you would be able to create like instances of this that match existing data planes, and the inspect API would work. Like all this would work for you for free.
yeah, so everything out of the box. And you just have to implement validation and XDS configuration.
Right.
So pretty simple. Okay, any other questions? Yes, so if no more questions for this, then oh, thanks. So yeah, I think we can move forward. I think Q&A can be the last part. So yeah, let's discuss Kubernetes probes. So am I saying the name correctly? Is it Jan?
Hello.
Hello.
Sorry. Yes, that's correct. My name is Jan Klimo,
Okay.
and I have joined. This meeting as currently we are working more and more with Kuma, and our applications also need to be more reliable. So we are kind of struggling a bit with the Kubernetes probes, most particular the gRPC one.
Mhm.
So basically, I just wanted to ask that if there is any roadmap for such topic, as it's currently, I'm not sure if it's correct, but looks like it's not covered by Kuma, I mean by the sidecar. So we are looking for workarounds, how to simply keep our applications on that level as we need. I mean the availability level. So yeah, basically that's it. So how you deal with the gRPC applications for now, guys? That's the main point.
Yeah, I guess I can answer this a little bit because we have gRPC applications in our cloud offering, and we also use Kuma in our cloud offering. Well, yeah, and usually the pattern that I saw is that there is a separate HTTP server that is used for, serving readiness probe and metrics and diagnostic stuff like that, right? So basically, then you use HTTP probe, which we support in a way that you probably looked into, right? That we have this virtual probe concept that we override Kubernetes probe, so Kubernetes can contact only this one endpoint without MTLS, right? Well, maybe my question is, are you talking about this new gRPC probe feature? Because I see that in Kubernetes 1.24.
24. Yes, that's correct, sir.
Yeah. Okay. So yeah, we definitely don't do anything about this, right? So like if we don't override those kind of probes, then we have basically this problem that application is secured by MTLS, right? And Kubernetes is trying to like contact the application. It requires MTLS and it cannot do probe, right?
That's correct.
This is probably what you saw. Yeah, I think we haven't discussed this. Probably we could do a similar thing like we do with HTTP probe, that we kind of override this, but I'm not sure how that would work with gRPC, so we can only expose like one method, let's say. How does it work? Like with gRPC, can you specify like a method or just part and that's it?
It's actually specified by that health configuration. Actually, on there is health checking interface. It should have. It's specified by gRPC community itself. Actually, you have a link in front of you. It's on the top of the page here, I think so. So you can, yeah, this is
one.
Yeah, that should be it. Or let me just send you the link. 1 second.
So you already have a gRPC server you have to implement, like just
Right.
start on your server and Kubernetes will know that, right? So you have to specify only port, essentially.
Yes, that's correct. Because you have specified this inside the application, this health checking protocol. And basically as you said before, the Kuma is just blocking this communication right now.
Right.
So we are not able to reach this endpoint.
Yeah, okay, so well-known health service. Right. So it seems
Yeah.
like we could do that, right?
Yeah, we definitely can, right? Because with HTTP we are exposing only like specific path, right? We could do the same here because the service is exposed like under the hood in HTTP2 under some specific path. So we can only we could only allow this path for health checking and that would work. Yeah, it's just it requires an implementation on our side.
Jan, is this something you're interested in contributing, maybe? If we help you find the places where you need to
Sure,
do it?
Sure, I'm definitely up to it, and we can also test it in our environment if it works well and give you the feedback afterwards.
Okay.
So, and it will be like plentiful used in our environment because we really rely on gRPC applications, and yeah, but traffic also kinda is growing day by day. So definitely something what we should going to utilize, and the containers are dying or not really helpful all the time. So this probe will be very helpful.
Yep. Okay, cool. Do you want so how about the next step is you open an issue, right?
Okay, perfect.
Kuma, and then we'll make sure we'll catch it and, you know, add the code pointers to help you like figure out where this needs to be added, and add a bit of context. And then we'll like feel free to ask more questions on the Slack and stuff, and someone from the team can help you get your contribution home, if that sounds good.
Perfect. Thanks.
Cool.
Thanks a lot, guys.
Well, thank you.
You're welcome.
Oh yeah, we have time, about 5 minutes, to discuss anything you want. So if you have any questions, please ask. Okay, if there are no questions, then thank you everyone. Have a good day and see you next time. Bye.
Bye.
Yeah.